In the last module, when we talked about Jablonski diagrams, we were typically interested in absorbance and emission as they were going from, or as you were doing electronic excitation, going from the ground state S0 up to an excited state such as S1, that first excited singlet state. And while in our discussion we talked about how each of these states actually has within the electronic excited state a variety of smaller vibrational excited states. But what was often missed in the Jablonski diagrams that you all were drawing as part of group work is that even at the ground state, we can have a variety of excited vibrational states, and that sometimes the excited vibrational states can actually be at similar energy to an electronic excited state as well. Okay? Our triplet excited state also has these vibrational states. All right, now as we start talking about FTIR, or Fourier transform infrared spectroscopy, what we're looking at here is not the transition of an electronic excitation, such as going from the ground state to the first singlet excited state, but rather we're looking strictly at vibrational excitation, where when our photon comes in, we get an excitation to some level of vibrational excitation. And so as we're looking at FTIR, I want you to think about these bond vibrations as not as an electronic excitation, but as a vibrational excitation, where our bond vibrations, as bonds are naturally vibrating according to a frequency, as they are excited, they will then vibrate more quickly at a higher frequency. Okay? And how the same way that we had transitions here that represented a specific amount of energy required to make an electronic transition, we also have specific vibrational transitions, and there's a specific amount of energy required for each of those as well. So as we think about our absorption of light triggering a vibrational excitation, the bonds present, as we're going to see, are going to be dictate which energy, which photon wavelengths or photon energies are going to be specifically absorbed.